It's fairly common knowledge that invasive species are an important problem, with habitats in and around Florida being prominent examples of the disaster effects they have on indigenous wildlife and native ecosystems. Burmese pythons, lionfish, and armored catfish infestations are likely the result of accidental, intentional, and careless releases of animals associated with the pet industry. Lionfish and Burmese pythons are voracious predators that are highly fecund, meaning they rapidly produce a lot of offspring. Armored catfish that consume algae and biofilms in home aquaria do the same thing in the wild and outcompete native manatees vis-a-vis common food sources. Of the three species of primates that have established breeding populations in Florida, two are Old World catarrhines with downward-oriented nostrils, rhesus macaques being from Asia, and vervet monkeys from Africa. Squirrel monkeys, although New World platyrrhines with sideways pointed nostrils, share common ancestry with Old World catarrhines and are thus relatively recent emigres to the Western Hemisphere, endemic to South America. Here's an interesting observation, though, about the geological history of Florida relative to the rest of the North American continent. The chunk of continental crust on which the present-day state of Florida resides was originally on the perimeter of Gondwana, whereas the bulk of the North American continent derives from Laurentia. Subduction that occurred when Pangaea formed welded this portion of Gondwana to Laurentia, and so after Pangaea rifted apart, the cards of the supercontinent's deck were shuffled. That presents an interesting question. By acknowledging and synthesizing the geological history of plate tectonics, we can reconcile and harmonize various observations about the biogeography or distribution, genetics, and evolutionary history of life. Mammals present a particularly illuminating set of examples. As previously mentioned, the consequent similarities of the New World and Old World primates due to their common ancestry and the separately derived differences they have accumulated since they diverged mirror the shared geological record of supercontinent pieces that then accumulate unique geological and fossil records after they separate. Species in the clade or superorder of marsupials known as Australodelphia that actually includes Australia, Asia, and one species from South America are all more closely related to one another. That is, they share a more recent common ancestor with one another than they do with placental mammals, even in cases where a particular Australian marsupial may look more like a placental mammal from another continent. Features that are unique to the species of superorder Xenarthra, both living and extinct, as well as their geographic distribution, point to a South American origin for their common ancestor. Furthermore, just as the rifting that separated Pangaea set the African and South American continents on different trajectories, so too has it done the same to the sister branch to Xenarthra, the African clade of placental mammals known as Afrotheria. A final mammalian clade that is intimately and unequivocally linked to the geology of plate tectonics, so much so that it is named after the paleocontinent on which its member species' most recent common ancestor resided, is Laurasia theria.